Yeah, children. So yesterday we were discussing about electromagnetism. So coming to electromagnetism, what are the topics we have discussed yesterday, children? So we discussed in electromagnetism the following topics. What are the topics we discussed in electromagnetism? Magnetic field I discussed, lines of force I discussed, and uh, after lines of force properties also I discussed of lines of force. Then I discussed about the swimming rule and snow rule, which gives the direction of deflection of compass kept near current carrying conductor. I told you. Next, then I discussed about the direction of magnetic field. Direction of magnetic field. For knowing that magnetic field, we will use right hand thumb rule and Maxwell corkscrew rule. I told, and around a straight conductor, magnetic field circular. I told, around the circular conductor, magnetic field is straight. I told, and the factors is that magnetic field depends directly on the current for this both and inversely on the radius. I told you all these topics. I told you. Today we will discuss an important topic called solenoid. What is solenoid? Solenoid is a circular turns of copper wire. Solenoid is a circular turns of copper wire wrapped in the shape of cylinder. When you connect both the ends to a battery, and if you keep any substance in this, it will behave as a magnet. When you pass current, switch it, it will solenoid will be like your watch, pen spring. The pen spring will be the same like the only bigger one. A circular turns of copper wire. Circular turns of copper wire. Circular turns of copper wire wrapped in the shape of cylinder. Wrapped in shape of cylinder. Circular turns of copper wire wrapped in shape of cylinder, children. Okay, it is same like that only it will be there. In that you keep any object. If you keep steel, it will become permanent magnet. If you keep steel and if you pass the current, it will become permanent magnet. Steel will become permanent. No, sir, I will keep soft iron means. If you keep soft iron in this, it will become temporary magnet. Then what is temporary magnet is your doubt. Temporary magnet means only when current is there it behaves as a magnet. Means still till the time you are passing the current it will behave as a magnet. Once you stop the current it will not behave as a magnet. Temporary magnets are called as electromagnets. Temporary magnets are called as electromagnets. What is an electromagnet? Electromagnet, see here. What is an electromagnet? Definition. Electromagnet is a substance which behave as a magnet. Substance which behave as a magnet. Substance which behave as a magnet only when current is passed. Only when current is passed. Substance which behaves as a magnet only when current is passed. It's called electromagnet. Okay, once you stop the current, it will stop behaving like a magnet. So, you want permanent magnets, you can prepare permanent magnet in solenoid. If you want electromagnets, you get electromagnet in solenoid. So, what is the function of solenoid? To make a substance into magnet. Okay, what is a solenoid? It is just a circular turns of copper wire. That's all. It's a circuit. That's all. In this, you keep any object, it will behave as a magnet only if current is passed. So if you keep steel, it will become permanent magnet. If you keep soft iron, it will become temporary magnet. So among permanent magnet and temporary magnet, which is better? Permanent or temporary? That is the question. Which is better? What do you feel? Anyone? What do you feel? Which is better? Permanent is better or temporary is better? Children, do you have any idea? So permanent magnets are there and temporary magnets are there. Temporary magnets are called electromagnets. So, which is better? Okay. So, children, what happens? Permanent magnets. Once you magnetize it, over, it will behave as a magnet. It will have certain reflectivity. That much magnet only it will become. But temporary magnet, you can magnetize to any extent. How much you want, that much you can magnetize. How much you want, you can magnetize that much. Temporary magnets, you can magnetize to any extent. How much you want, you can magnetize that much. This will have limit. This will not have any limit. And here, once North Pole and South Pole is formed, it is permanent. You cannot change them. You cannot change polarity. But here, North and South Pole, you can change. North and South Pole you can change. How you can change means see, children, this is a magnet, isn't it? This is becoming magnet, North Pole and South Pole. I want this as south, this as north means I will take out the battery, I will reverse the polarity. If you reverse the polarity, this will become north, this will become south. So in temporary magnets, however you want, whenever you want, you can change the polarity. You can increase the strength. You can change the polarity. Whenever you want, you can increase or you can decrease the. Okay. Now this permanent magnet means you will stay. Temporary magnet means soft iron. Okay. And here it is permanent. It is permanently getting magnetized, children. Okay. And remember, children, here the polar it can be easily demagnetized, children. Which one? Permanent this time permanent magnets cannot be demagnetized. Cannot be demagnetized. Whereas temporary magnetics you can easily demagnetize. How you can demagnetize? Stop the current. That's all. If you stop the current, it will stop behaving as a magnet. Okay. Are there any uses for electromagnets? So many uses are there. So many uses are there. What are the uses? It is used in cranes in lifting heavy loads. Okay. It is also used in alarms and also removing the pairs in scientific research. So many other. Okay. I will discuss the construction of alarm also now. Okay. So now here what we will discuss means suppose imagine there is a heavy load of imagine 20,000 kg load is there iron. This is your crane. This is your crane. This crane is used to lift this load. Now this one crane will have one which is lifting. We will use always electromagnet. Electromagnet. Why? Whenever you want to lift the load, you will switch on the current. When you switch on the current, this will behave as a magnet and it will go and attach to this. Wherever you want, you will go there and you will switch off the current. Once you switch off the current, you will come and fall down. No one will use here permanent magnets because if it goes and attaches, it will permanently attach. So electromagnets only they will use. Why electromagnets they will use? Whenever they want, you will get magnetism. Whenever you don't want, switch off the current, magnetism will go away. So what are electromagnets? Substance which behave as a magnet only when current is passed. Okay, the best example of electromagnet is used in making alarms. Okay, I will show the construction of alarm or the situation. Construction of alarm. Take a horseshoe magnet. Horseshoe magnet. This is horseshoe magnet. Okay. So now what we will do? Here we will wind up the wire. Means we are winding up the wire. Okay. This is horseshoe magnet. Horseshoe magnet means children is an electromagnet. This is an electromagnet. Soft iron. Okay. So this solenoid I am preparing. One wire and keep it like this. Take here one wire and keep it. Okay. This is attached to a circuit. This is attached to a circuit. This is attached to a circuit. Now what happens? Here another is there. Here another is there. Try to understand. See here. So what happens? This will have one wire like this. This will have one wire. This is attached to this here. Of course, switch will be there. This is switch. So what happens? Try to see here. Here, what happens means children say here using a spring, here with some holder, I will hold a tongue. Means a steel thing which is made. And here, what happens? Okay, children, try to see. This is somewhat construction of alarm, children. Alarm. Okay, children. So what happens? Slowly you see, children. Slowly. One end is connected here. One end is connected here. Wire. One end is connected to this, children. One end is connected here. This is connection. So children, this side will switch on. If you put the dot, it is switch on. Once I switch on, children, see here slowly now current is going. When current is going, this will behave as a magnet. When current is going, children, this will behave as a magnet. When this is behaving as a magnet, this whole thing will try to come closer because this is made up of iron. This whole thing will try to come closer. When it tries to come closer, this will go and hit this. But when this is coming upward, down it will go like this much. Down it will go like this. Try to understand, children. Okay, children? You try to understand, children, like this it is there. Okay? It is coming, it is going and hitting. If it goes and hit, this will go back, children. This will go back. When it is, this will go back. If this is going back, here connection is lost. Here when connection is lost, current will stop. Here when current is stopped, it will stop behaving like a magnet. When here it stops behaving like a magnet, again it will go back. Again it will go back. When it goes back, again it will come and touch this. Again when it is touching, current is flowing. When again current is flowing, this will behave as a magnet. When this behaving as a magnet, it will try to come closer to this. Again it will go and hit. But once this is hitting, this will go back. When this is going back, current is stopped because here circuit is broken. When circuit is broken, again this will stop behaving as a magnet because there is no current flow. When this is not behaving like a magnet, it will go again far. When this is going far, this downward will come and touch this. Again now current will flow. When current is flowing, this will behave as a magnet. This will try to come closer. When this is coming closer, this will go back. Again current is stopped. Again current is stopped means this will stop behaving like a magnet and this will go away. When this is going away, this will come and touch this. Like this, when you switch on, alarm is continuously, it will go hit, come back, go hit, come back, go hit, come back, go hit, come back. That will give you like a alarm sound. This is what happening. This is a connection, children. Basic connection is there in your textbooks also. Please try to learn it and read and then you understand. Like this you have. Okay, children. So this is the alarm piece, children. So working on the alarm piece. Now we will do some questions, children. If you do some questions, then you will understand, children. 3-4 questions I will done, children. Then you will understand. First question. Okay, first question, children. First question. If you know, you can tell children. Definitely you won't open your mouth to play more. By using a compass needle. Okay, this is describe. Okay, children, describe application type. This is not, this is how. This is there like this, children. This is a question they are giving. So like this, it is there. Okay, it is a solenoid, children. It is a solenoid. Children, the diagram shows a small magnet placed near the solenoid. Small magnet is placed near the solenoid AB with a north pole at one end. Current is switched on in the solenoid by pressing the key. Okay, children, state the polarity of A and B. State the polarities of A and B. So, children, when current is switched on, what will be the polarity at A and what will be the polarity at B? This is the question, children. So, children, for this we should remember one important concept. I will say, children. See, children, when current always flows from positive to negative, current is going like this. Current is going like this. Coming, going. Can anyone say what is the direction of current, children? Clockwise or anti-clockwise? Anyone? Can anyone at least open your mouth and say what is it, clockwise or anti-clockwise?
Clockwise.
See here, is it clockwise or anti-clockwise? Say clearly, anyone? Is it clockwise or anti-clockwise here?
Clockwise, sir.
Yeah, it is clockwise. So children, always remember, if you see from this side, it will be clockwise. If you see from this side, it will be clockwise. And if you see from this side, it will appear as if it is anti-clockwise. So because this side it is appearing clockwise, try to understand, always remember like this. North means anti-clockwise. North means anti-clockwise. South means clockwise. Like that, easy to remember. See, south is clockwise. South is clockwise. North is anti-clockwise. North is anti-clockwise. So children, clockwise means south. So this pole, because here anti-clockwise it is going. This pole is south pole, and this pole is north pole. And north and south are there, so this will go and attract to this. Whenever in a solenoid, if current is flowing, whenever in a solenoid, if current is flowing, remember it behaves as a bar magnet, and because it is a bar magnet, you will have lines of force. I told you And inside the solenoid, magnetic field is uniform. Solenoid acts as a bar magnet. Remember, solenoid acts as a bar magnet. It will have one north pole, it will have one south pole, it will have lines of force. And inside the solenoid, magnetic field is uniform. Uniform magnetic field is represented like this. Uniform magnetic field is represented like this. Okay, one more question. Given the text. One more question. One more question. See here. Is there like this somewhat? See, children, there is a question like this. Okay. So from back they are showing. From back they are showing like this. Like this they are showing. Okay. So okay. And it's going like this. And here negative, here positive. Okay. Like this they are showing. Like this they are showing. So here is a compass. Here is a compass. Here is a compass. Okay. And here is they have given directions: north, west, east, south. This is the question, children. The diagram shows a spiral coil wound on a hollow cardboard AB. Magnetic compass is placed close to it. Current is switched on. Current is switched on. Current is passed. Switched on is put dot. Current is switched on. By closing the key, what will be the polarity at the ends of A and B? How will the compass needle be affected? Give reason. Okay, children, what will be at A and at B? Okay, children, so current always flows like this, children, like this. It is going, okay, like this, it is going, children. This is going like this, children. Children, this is going like this. Okay, so positive to negative it will go. It is going like this, children. Here it is going like this, like this, like this. It is coming. So current is going like this, like this, like this, like this, like this, and coming back. This is anti-clockwise, and here it is clockwise. Here it is clockwise. Children, here it is clockwise. See here, it is going like this. If you see from this side, it is clockwise. So this is south, children, and here it appears. If it is south here, automatically that will be north. Okay, and so children, this is north pole. If this is north pole, the compass will be, this is also north pole, children. Always compass is north, this is south. This will try to go away, no, children. So it will deflect towards left, means west. Why? Because north and north repel. North and north will repel. So it will try to go away. This will try to go away. So it will deflect towards west, you should say. Because this is west, this is east. It will deflect towards west. Like that you should say. Okay, children? Like this question, these are application varieties, children. These are application varieties. One more question will be any application varieties will do. Okay. So state the two ways by which electromagnet strength can be increased. This is electromagnet. How can we increase its strength, children? So if you were anyone asked in a solenoid how to increase the strength of electromagnet, means these are called terms, children. These are called terms. See, these are called terms. How many terms you keep? How many terms you keep? That much strong electromagnet it will become. And also by increasing the current, more is the current, more will be the strength of the magnet. So whatever two factors on the solenoid depends N and I. By increasing the turns, by increasing the current, you can increase the strength of the solenoid. You can increase the strength of the solenoid like this. Okay, so check, this is about solenoid, children. Yes, children. Shall we do some more questions, children? You want some more questions?
Yeah, sir.
Yes, children. So questions based on the solenoid if you want. What is the directional magnetic field if current is flowing in clockwise? Children, if current is flowing, if current is flowing in clockwise. If current is flowing in clockwise, what did I say, children? South direction. This is clockwise, no? Clockwise means south direction. South direction. And anti-clockwise means north direction. Anti-clockwise means north direction. Name and state the rule by which the polarity of an ends of current carrying solenoid is determined. What is the rule, children? How do you determine at the ends of the solenoid if current is there or not? I mean, say what are the polarities? How do you find out, children? Yes, anyone? Means on what basis? What is this rule called? Clockwise means I said south. Anti-clock. So what is this called, children? What is this called? This is just a rule, children. What is the name of this rule? Means a direction rule, children. This is called direction rule. That's it. What is the name of this rule? Means clock rule, or you say clock rule. This is called a clock rule, children. Okay. What is clock rule? Means clockwise means south, anti-clockwise means north. Clockwise means south, anti-clockwise means north, children. This is called what rule, children? Clock rule. Okay. Next step. A wire is bent in the form of a circle. A wire is bent in the form of a circle. Okay. Current is flowing in anti-clockwise direction. If current is flowing in anti-clockwise direction, this is front, this is back. Front will behave as a north pole, and of course back will behave as a south. Okay, children. So like this questions will come, children. One more question.
Yes, sir.
Question. Children, next question. Have you 1 second. One more question, children. Here, A and B represents two types. Children. A and B represents two straight wires carrying equal currents. Children, A, K, B, like this. Children. A and B represents two straight wires carrying equal currents in a direction normal in the plane of paper inwards. Children, inwards means cross, then outwards means dot always. Inwards means cross, outwards means dot. Okay, so here what is the current? Say like this plane of the paper they are putting, children. Inverse means like this it is going, children. Okay, okay. So children, question is here magnetic straight conductor is there, here straight conductor is there. So children, here current is going down, children. Current is going down like this, children. Current is going down. See my thumb. Thumb gives direction. So my curling of fingers like this. What is this direction, children? What is this direction? My curling of fingers is in clockwise direction. So you have to put like this. You have to put like this, and you have to show clockwise like this, clockwise. Because current is flowing south. Inverse means south. South means according to right hand thumb rule, south current. My thumb gives the south current. Then curling of fingers is in clockwise. And here also same, children. Here also same, because this is also this side current is flowing down. So when current is flowing down, here also same clockwise. Okay, children. And okay, children, that's it. They have to skip separately the magnetic field lines produced by what is the magnetic field at the midpoint of the line joining A and B. Give the examples, children. First, second question here. What is the magnetic field at the point A due to this and this? This and this will cancel each other, and here you get zero magnetic field, children. Okay, here and here equal. Okay, children. Third one. When will the magnetic needle of compass rest if it is placed at point K? How will the magnetic needle of compass? Children, here if I keep compass, okay, in which direction will it show? It will not show any direction, children, just it will remain like this, showing geographical north and south. That's all. Because here it is cancelled, no, children. This is acting, this is acting. It won't move anywhere, children. Last one. What will be the effect of magnetic field at the point K? The current on a wire B is reversal. Here, current is going now upward. If current is going upward, now the magnetic field is acting like this direction. This is clockwise, this is anti-clockwise, children. So on reversing the direction of current in the wire B, what happens? So due to current, why we are reversing the, okay, it's becoming downwards in the plane of paper, then both the magnetic fields here A and B at the point K gets added. So net magnetic field at the point K will be downward in the plane of paper, children. See here, children, see what happens. Here we are reversing the current. Only here, means initially it is coming downwards, now we are sending upward. Here we are reversing the direction of current, means direction of the direction of magnetic field also is changing, children. It is becoming here anti-clockwise. Here it was clockwise. Here it is becoming anti-clockwise. So now both the magnetic fields here and here, it gets added at point K. It gets added. That's all. You just write down. It gets added up. It won't get cancelled, children. If both are in the same direction, then only it gets cancelled. But in this direction, it gets added up. It gets added up. Okay, children. So like this questions they are asking children.
Yes, sir.
So try to understand, children. The current is going down. So my hand fingers are going like this, children. My fingers are going like this, so clockwise. Clockwise only I'm showing here. If current is going upward, anti-clockwise. If current is going upward, anti-clockwise, children.
Got it, sir.
Okay, children. So some more questions if you want, be able to watch it.